This is your review for the online midterm in college algebra. We're going to call this key. Let me remind you that as I go through this, if you need to pause it or rewind it, do so please, because I may go through it at a little bit faster pace, but just please rewind it, pause it, stop it, what you need to. Evaluate the expression or indicate that the root is not a real number. Notice here the negative is outside the radical. That means what you're going to do is you're going to take the square root of 49, which we know to be 7. The square root of 49 is 7, and then what's out front? The negative. So you're going to put the negative in front. So negative 7 is your answer, which is going to be answer choice B. Answer choice B there. Negative 7. All right. So now we have evaluate the radical expressions or indicate that the root is not a real number. So since it says that, let's talk about when is something not a real number. That's whenever you take the square root or even root, so second root, fourth root, sixth root, eighth root, an even root, 52nd root, 144th root. Even root of a negative number is not real. Okay, it's not a real number. We'll do those with i's and imaginary numbers, but it's not a real number. So here, the fourth root of 625. So what we want to do is, what do we multiply together? 4 times itself, something times something times something times something to get 625. So if you think about 5, because that's the choices up here, but it also ends in 5. 5 times 5 is 25, right? 25 times 5, 5 quarters is $1.25. And then if you take $1.25 or 125 times 5, you end up with 625. So here, the fourth root of this is 5. 5 times 5 times 5 times 5 is that. So then both of these answers here are going to be B. B and B for the first two here. All right, let's move on to the number 3. Factor the trinomial or state that it's prime. So here, this is going to be 3 terms, right? 1, 2, 3, 3 terms. The leading coefficient's 1, and there's no GCF. This is the list method. Automatically identify list method, all right? Or whatever method you use, that's what I call it, but if you have a different method, that's fine. So list method here. So what I'm going to do is the factors of 8 that subtract to give me 2. Right? The factors of 8 subtract to give me 2. So I need the factors of 8, 1 and 8, 2 and 4. 4 minus 2 is 2, right? That subtracts to give me 2. So what I'm going to do here, I'm going to have my x has got to go first because that's got to give me x squared, what I have there, right? Got to have that x squared. So then I need the 2 and the 4 because that's going to be 8. And then I look back at the signs. This negative means they're different. I don't mean these two up here. That's not what I mean. This means they're different down here in the answer. Well, how are they different? Well, the bigger number gets the first sign. So which one of these bigger factor? This one's bigger, so it gets that plus right there. All right? So the 4 gets a plus, and since they're different, the 2 gets a minus. So there is your factored form, x minus 2 times x plus 4. So if we look, it's not A. That's got x plus 1 in it, right? That's not part of x minus 4, neither one of those. And then if we look at B, x plus 4 is here and x minus 2 is here. It's in a different order, but it's the same exact 2 parentheses, so it is indeed B. Now we're going to just check. Nope. That's the sign's wrong, and then it's not prime. So it is also indeed B. All right? I promise you something else will be an answer at some point, but right now the first 3 are B. Factor the difference of 2 squares. It even tells you that it's the difference of 2 squares. I would not tell you that if I had not gotten this from a test bank. I would just say factor completely for all these. So right here, 2 terms, it's a minus. Both of the powers are even, and also 121 and 16 are perfect squares. That's all the requirements to be the difference of squares. So then when we factor this, the first half of the parenthesis has to give me 16x squared when I multiply it by itself. So 4 times 4 is 16, right? X. So the first part of each parenthesis is going to be 4x. What's going to be the last part of it? Well, how do you get 121y squared? Well, 121 is 11, and then you also need the y on it, right? And then how do you get minus 121 squared, or how do you do the difference of squares? One's positive and the other is negative. So 4x plus 11y, 4x minus 11y, which on this one, if we look at it, is actually C. Actually C. You cannot write these two parentheses as something squared like choices A and B because plus and minus. You cannot write them as something squared. They're different. They have to be completely identical to write them as something squared. Number 5, multiply or divide is indicated. So here we have a fraction divided by another fraction. So that's keep, change, flip, right? Keep, change, and flip. So we're going to keep the first fraction. What are we changing here? We're changing the division to multiplication. So we're going to change it to a dot for times. X squared plus 8x plus 15 over x squared plus 3x. And here I'm going to get some other colors involved. I'm going to factor this first numerator with gray. So let's do that. 3 terms, no GCF. The leading coefficient is a 1 here. That's list method again. This is list method. My list is going to be 1 and 18, 2 and 9, 3 and 6. I want the ones that add to give me 9. That's going to be 3 and 6. So this is going to be x and 6 and x and 3. You say, well, Mr. Guest, you put the 3 first last time or the smaller number first. It doesn't matter. Right? Remember, it doesn't matter what order. What matters is plus 6 or minus 6, plus 3 or minus 3. So here, again, this plus sign right here, that plus sign says both of them are this. So they're both positive. That plus says they're the same. They're both, and then they're both whatever the first sign is, which is positive in this case. So now I'm going to take the next one in the denominator underneath it, and it's also 3 terms, no GCF, 1 in the front. So it is also list method again. To get x squared, you have to have x times x. And I'm going to go ahead and put my times in here because that's coming in just a minute. And so I need to list 1 and 30, 2 and 15, 3 and 10, no 4, and then 5 and 6. So I want the factors of 30 that do what? The factors of 30 that add to give me 11. What are they? That's right, 5 and 6. So we're going to put in here 5 and 6. And again, both signs are the same. They're positive in this case. And I don't mean they're the same there. This right here alone tells me they're the same in my answer down here. And then they're both that one. All right? So that's where that comes from. So now let's keep going. Now we're going to take this one in blue. And we're going to say, okay, this is going to be x squared plus 8x plus 15. Well, again, 3 terms, no GCF, and a 1 in the front. It is list method. 1 and 15, 3 and 5. 3 and 5 add to give me 8. That's what I needed. And then both signs are positive, right? So we need a 3 and a 5, and they are both positive. And then the final piece of factoring, right? We've had to factor 4 different things now after we do this next one, right? We've already factored 3. We're going to factor a 4th polynomial here. We have an extra stray mark over here. Let's fix it. All right, so x squared plus 3x. It's 2 terms. That's either going to be a GCF, difference of squares, or SOPs. If we look for a GCF, which is the first thing we're supposed to do, right? We already talked about it. None of the other ones had it. This one has an x. If I take that x out, then I'm left with x plus 3. And now everything is factored. So now I'm finally ready to start dividing out if I can, because everything's factored. When you have everything factored, it's like this right here is not even there. It's like it's one big fraction and everything in the top's in parentheses multiplied, right? And I know it's all factored. No pluses and minuses are outside parentheses unless there's a leading negative, which is here there's not. And then no powers are bigger than 1 in the parentheses. So that I'm good. There's no GCF in any parentheses. So x plus 6 is gone. That divides out. You might say cancel, but it really divides out. X plus 3 is also gone, even though one's on the left, one's on the right. This x plus 3 here stays because you don't have another one to divide out with it. And then x plus 5 is also gone there. So what am I left with when I do this? Well, I'm left with an x plus 3 in blue over an x in orange. And that is my final answer. X plus 3 divided by x. Do you see that answer here on number 5? And you do. It is D. So then D is our final answer here for number 5. Add or subtract is indicated. So this is number 6. 3 over x plus 6 over x minus 9. So when you add or subtract fractions, right? This is different than when you're multiplying or dividing fractions. The last one was dividing, so we could do all those things we did. Here, these denominators are not the same, and you cannot add two fractions unless the denominators are the same. So what we first need to do is factor this. Can we factor x? No. Can we factor x minus 9? No. So those are already factored, so my LCD has to have everything from each denominator that's factored, an x and an x minus 9. So I like to do this, x times x minus 9. There's my LCD. And you see that in a couple of the answers here, and you see 9 minus x, which is just turned around. That's if there's an extra negative, they just did that. So here, 3 over x, and I'm going to leave some space because when I look at this, it doesn't match that completely. That's why I'm going to leave space because I got to multiply by what's missing. Plus 6 over x minus 9. So let's go in here. What's missing here in this denominator to get that whole thing? Right, this whole thing here. And that's going to be the x minus 9, right? So if I put x minus 9 down here, I got to put x minus 9 up here. And then what's missing here to get this whole thing here? The x, right? So we need to take this and multiply by x over x. And now we have 3 times x minus 9 over x times x minus 9 plus 6 times x over x times x minus 9. Now I know the x minus 9 is first here. I just brought this in the front because you're multiplying. And now these two denominators are the same, right? So I don't need to have two fractions. I can have 3, and I'm doing a lot of extra work here. Hopefully you can do this much quicker than I'm doing it here. X times x minus, or you need to practice until you can. If you take longer than me, then you definitely need to practice and get faster than me on this, for me explaining it. So distribute the 3. Let me come up here. We're going to have 3x minus 27 plus 6x, which is over x times x minus 9. And then we notice that, hey, wait a minute. This and this go together. That's going to be what? 9x minus 27 over x times x minus 9. Now, I see that answer. If I was working this problem, I'm going to say, hey, a 9 and a 27 has something in common. I'm going to factor that out. But here, since this answer is exactly right here, nope, that's not it. Since this answer right here is where? Right here. Then, why was it not B, by the way? Because look at the order here. 9 minus x is not the same thing as x minus 9. That's why I just saw the 9x minus 27 and went to circle it. But it's actually this one, A. It's actually A here. All right? And you definitely would want to factor that, by the way. Let me go back. If this became, see, it would be 9 times x minus 3. And I noticed that doesn't divide out down here, right? So then that's why I didn't have to worry about it. That's why they didn't do it. I still would have factored it, left it 9, x minus 3 over x, but that's not how they have it. And you have to choose the answers that they have there, right? So here, solve this and check it. If you were writing this for me on paper, I would have to see the checking, but because it's online, solve it. And it's always a good idea to check. Always a good idea to check. So 2 and then, oh, wait a minute, I just used that. 2, 3x minus 1 plus, I'm just going to write the whole thing down first. I'm going to write the whole thing down. And then I'm going to say, okay, the first thing I do is take this 4 and distribute it. So 2, 3x minus 1 plus 4x plus 4 equals negative 7x minus 3. And again, I'm going to take every step here. You got to go in the right order. So 3x and 4x, that's going to be 2 bracket 7x. And then minus 1 and plus 4 is going to be plus 3 equals negative 7x minus 3. And then we say, okay, we've done everything we can in here. Now it's time to do what? Distribute that 2. 14x plus 6 equals negative 7x minus 3. And then I want you to be good enough to do this. I want you to decide what to move. I'm going to choose to move the negative 7x by adding it to both sides. But it's not wrong for you to move the 14x to the right. It doesn't matter. That cancels. The other thing I want to do, and that cancels because it goes to 0, I also say, look, I canceled the x's over here, right? So I need to cancel the numbers on this side. I need to get rid of that plus 6. So how do I do that? I subtract 6 from both sides. That cancels. So I'm left with then, when I do that, I'm left with 21x equals negative 9. That's negative 9, right? So I'm going to bring this up here. 21x equals negative 9. Now, how do you suppose I solve this now? I divide both sides by 21. So x equals negative 9 over 21. But wait a minute. Wait just a cotton picking minute. 3 goes into 9 3 times, and that's 7 times. So this is negative 3/7. So x equals negative 3/7. Is that one of our answers? Yes, and you'll notice they have these squiggly brackets around negative 3/7. All right, so that's just, you just have to know, that's saying it's a solution set with only one element or one number, which is negative 3/7. So I wrote it x equals, they wrote it as a solution set, sorry. And so that one was B. That one was B. All right. 8 and 9 are both solve the formula for the specified value. So D equals RT. We have D equals RT, and we want to solve it for T right here, right? Solve it for that variable right there. So how do I do that? Well, I need to undo addition and subtraction first, but there's nothing added or subtracted. So the only thing I do is get rid of that R that is multiplied by the T. That's what letters mean written by each other, right? So how do you undo multiplication? You divide, right? So then D over little r equals T. And look, this is also the same thing as T equals little d over r. You can't flip the r into d, but T equals doesn't matter what side it's on. So do you see T equals d over r anywhere here on this one? And that's going to be C. C is that one. T equals d over r. Number 9, perimeter of a rectangle, 2 times L plus 2 times W, 2 times the length plus 2 times the width. Solve for W. So P equals 2L plus 2W. So I'm solving for this piece right here. So if I do that, I need to get rid of this term because it's being added to it. Get rid of that first. So I need to subtract 2L from both sides. And I get P minus 2L equals 2W. And then what do? Well, I divide both sides by 2 because I want to get W by itself. So we have P minus 2L over 2 equals W because this divides out and becomes 1. So do I see that anywhere? P minus 2L over 2 is W. How else could I write that, by the way? Does it matter what side the W is on? Right, it could be W equals P minus 2L over 2. That's exactly the same thing. Just W equals is written on the other side. And that is going to be answer choice B. Right, P minus 2L over 2 equals W. Yep, so B. All right, if you notice I skipped number 10. That's because it's really short. I'll come back to it. I put it on the next page. But let's do 11, and then I'll jump back to 10 on the next page and pick it up before 12. All right? So it's the only time I go out of order, I think, this whole time. It's just the way it fit on the screens rather than use a whole new screen. So here, first write the values that make the denominator 0, then solve. Anytime you have variables in the denominator, you always do that. You want to make sure that you exclude from the domain anything that makes the denominator 0. So the first thing I need to do is find my LCD, and that means factor this. This is over 1. That's not going to contribute, and factor that. Well, guess what? That's already factored. The only denominator I have other than 1 is x minus 9. That makes my life a lot easier because now when I go to find my restrictions, which is what that first thing is talking about, my restrictions here, that's what this means, find the restrictions, then x minus 9 can't be what? 0, because it says find the values that make the denominator 0. So then I'm going to add 9, and what do I get? I get x cannot be 9. And that's going to be the first part. And if you look, that's either going to be A or B. That's negative 9 and negative 9. So those two cannot be answers. You with me? Those two cannot be answers. So we can get any number in the world we want to, but we can't get 9. So let's solve it and see what we get. Let's solve it and see just what we get. 20 over x minus 9 plus, you know what, I'm going to go straight into this. When I solve equations like this that have fractions, I multiply everything on both sides by the LCD. So go back and watch the videos if you didn't or don't understand. That's what I'm doing. I'm multiplying this LCD by this term, and this term. That's 3 terms. All right, even the 5. So then plus 5 times my LCD equals 30 over x minus 9. Oh, hang on. I didn't change colors. X minus 9. And then plus 5. And I'm also going to multiply that by my LCD. I don't need that in parentheses, just one thing. X minus 9. And then this is going to equal 30 over x minus 9. And guess what I'm going to multiply that by? You're right, the LCD. Every single time. What that does, if I multiply every term on both sides of the equation by the LCD, when it's an equation, that means it's got equals in it. When I do that, then that's going to eliminate my fractions right off the bat, which should make me really happy. This is over 1. This is over 1. I don't need this over 1 because it's not times a fraction. So these divide out, right? One's on the top, one's on the bottom, numerator, denominator. This is going to be 20 plus, if you want to go ahead and distribute here, you can. I would just be careful. Don't be careless if you do that. Equals. And again, these divide out, and I'm left with just good old 30. So I know that this and this go together. So this is going to be 5x. I'm just going to bring that down. 20 minus 45 is negative 25 equals 30. And then what do? I'm going to add 25 to both sides. So 5x equals 55. And then finally, what do? I divide both sides by 5. And do I get 9? Right? Because we said we couldn't get 9. I get 11. And that means that's good to go. That's 11. So again, they put it in the solution set. So this is going to be A, where this part's here, and this part is here. So then A for number 11. A for number 11. All right, bounce back to 10. 4 minus 4i plus 7 plus 2i, add or subtract is indicated. So then, wait, 11. Oh, yes, A. Just making sure. And then 10, let's see. So this is imaginary numbers, and they just work just like normal. This plus doesn't change any signs. We're going to get 4 minus 4i plus 7 plus 2i. This plus is not that. It's because that 7 has an understood positive. So let's see what we have here. If we put these together, we have 4 plus 7, which is 11. And then this and this. Hang on. The board's doing something crazy, so it usually fixes it. Negative 4i plus 2i is negative 2i. So 11 minus 2i, which is D. 11 minus 2i, which is D. Number 12 says solve by factoring. The first thing you have to do is get the whole thing equal to 0. Well, guess what? This is already equal to 0. Then the second thing you do is factor it. 3 terms, no GCF, 1 in the front. That's list method. X and X. I need the list for 48. 1 and 48. You might already see it. If you do, just go ahead and work with it. 2 and 24. This is the one that's left out the most. 3 and 16. 4 and 12, because that's on your times tables, and half of it's easy. 5 doesn't work. 6 and 8. So I want the ones that subtract to give me 8. Well, it's not going to be 8 and 6. That subtracts to give me 2. 12 minus 4, guess what? That's 8, isn't it? So 4 and 12, and that's equal 0, by the way. And now the signs are different. The bigger number gets a plus. 12's bigger. 12, I should say bigger factor. 12's bigger, gets the minus. No, it doesn't. I did that wrong. Bigger number gets the plus. 12 gets the plus. 4 gets the negative or the minus. Then I take each one of these and set them equal to 0, right? Once I get the factored form, right? The factored form equal to 0, I take this factor equal to 0 and this factor equal to 0. So now we add 4. And here we subtract 12, right? Just like you saw stuff all the time. So then x equals 4 or negative 12, which is A. That is A for that one, number 12. 5x squared minus 19x equals 4. We're still solving by factoring. Is this equal to 0? No. That means we got to move this 4 over. How do I do that? Well, 5x squared minus 19x equals 4. I'm going to subtract 4 from both sides. Now, I wrote this 4 here. It's not really under either one of those because it's not like either one of them. It's not a like term. So I didn't do it. I just wrote it over there. So then that's going to cancel and be equals 0. If you're factoring, you want all of this in descending order. None of those are like terms. You cannot combine them. Don't try to make that negative 4 go with the 19, negative 19 to the 5. So 5x squared minus 19x minus 4. Now what do I do? Well, it's equal to 0. And now you got 3 terms, no GCF, and not a 1 in the front. This is bottoms up. This is bottoms up. So I'm going to take the 5 times the 4. And in my thought cloud, I'm going to come out here in my thought cloud. I have x squared, correct, because the 5 moved, minus 19x, minus 5 times 4 is 20. So x squared minus 19x minus 20. So let's see what we have here. We have 3 terms, no GCF, 1 in the front. This is list method. 1 and 20, 2 and 10, 3 doesn't work, 4 and 5. Oh, wait, no. So it's going to be x and x. To subtract to give me 19, 1 and 20. So then, if you recall, bigger number gets this sign. Let me go ahead and do that in brown. Bigger number gets this sign. So 20 is bigger, it gets the negative because that's the sign that goes there. And then this says they're different, so that changes. So it's going to be a plus because this was minus. It's got to be different. And then finally, for bottoms up, we have to come back and divide by what we multiplied by on both these. So 1 over 5 doesn't simplify. That's what comes up here. So this is going to become 5x plus 1. And then the other parenthesis is going to be what? This is going to be 4 over 1. So that's going to just be x minus 4. And then I take each one of those, 5x plus 1 equals 0, or x minus 4 equals 0. Subtract 1, 5x equals negative 1, divide by 5, and I'm going to have to come out here to the side. X equals negative 1/5, comma, because it's going to equal something else. We're going to add 4 here. X equals 4, so negative 1/5, comma 4. Do you see that one up here anywhere? Yes. D indeed. D indeed. Remember, pause and rewind if you need to. Here, solve the equation by the method of your choice. When I see this, I see something squared on this side equals a perfect square. I'm using the square root property. We use the square root property. So 6x plus 7 equals plus or minus the square root of 36. That's what the square root property says. You do not put the square root of both sides. You do not do that. That is incorrect. The math that leads you there is how you get there, but nobody ever writes all the steps down, so you miss it when you do that. Don't do it. It's not that. It's not the square root of both sides. It's not what it is, because the square root of 36 does not have the plus or minus on it. 6x plus 7 equals plus or minus 6, and there's 2 ways you can do this. What I like to do is I like to take this and separate it out into 2 equations. 6x plus 7 equals the plus 6, or 6x plus 7 equals the minus 6. That's what I do. So we're going to subtract 7. 6x equals negative 1. We're going to divide by 6. We get x equals negative 1/6. And then over here we're going to subtract 7. We get 6x equals negative 13. We divide by 6. And we get x equals negative 13 over 6. So when we take this over here to write it down, we get x is equal to negative 1/6. Hang on, I was doing that goofy thing. Negative 13/6. So do you see those answers up here somewhere? That looks like it is C. So 14 is C indeed. It is C indeed. Solve by factoring and then use the zero product principle. The zero product principle just says if you have it factored, then each factor could equal 0, each individual factor. So if I look at this, it's equal to 0. That's good. How many terms? I have 1, 2, 3 terms. So do they have anything in common like a GCF or as a GCF? And the answer is yes. They have x. So then x, and then I'm left with x squared because I took one of the 3 out, plus 10x. I took one of the 2 out, plus I took the x out, so it's just 24. Well, let's see. X is out front. This looks like a list method, right? 3 terms, no GCF, 1 in the front. Factors of 24. 1 and 24, 2 and 12, 3 and 8, 4 and 6. Then you go back to 6 and 4. 5 doesn't work. Factors of 24 that add to give you 10, 4 and 10, 4 and 6, right? And then they're both positive. This is both positive. That's equal to 0. Now this is completely factored. So since it's completely factored, what do? I set each one of these things equal to 0. So x is 0 or x, hang on. Doing that thing, you said extra line on it. So or x plus 4 equals 0 or x plus 6 equals 0. So then if I solve this one, x equals 0, that's already solved. That's one of my answers. Minus 4 on both sides here, and I get x equals negative 4. And then I'm going to subtract 6 here, and I get x equals negative 6. So then I have 3 answers. I have x equals 0, negative 4, and negative 6 in no particular order. So do you see an answer that has all those in it? 0, negative 6, and negative 4 is going to be A here. A. Don't forget 0 is one of your answers. You have that x out front, right? Solve the radical equation. Anytime you raise both sides to a power, which is what you're going to do with a radical equation, you must check your answers. Many times, one answer will work and one will not. You get 2 answers. Sometimes you get 2 answers and neither answer works. Sometimes you get 2 answers and both answers work. That's why you must check your answers. Even it says to check them here, but even though it's online, you got to check them or you're not going to get it right unless you just guess it right. So square root of x plus 5 equals 3. So what we're going to do is we're going to take and square both sides of the equation. If I square a radical, I end up with x plus 5 equals 3 squared is 9. And then I'm going to subtract 5 from both sides, and we get x equals 4. That's the only answer I got, so let's check it. Check. X equals 4. So my equation original was square root of something plus 5 equals 3. Well, the thing that I plug in is what I found, 4. So look, it doesn't matter if those parentheses are there. What is 4 plus 5? 9 under the radical. And the square root of 9 is what? 3. It's not plus or minus 3. It's just 3. That checks out, doesn't it? So my answer then is x equals 4, which is in the squiggly brackets, right? 4, right here, B. So then for 16, the answer is B. Solve the absolute value equation. So that was a radical. Now here's an absolute value. To solve the absolute value, remember absolute value is the distance from 0. So the first thing you need to do is get the absolute value by itself. In this case, here's the equals. This is already by itself. You're good. It has no solutions if it's equal to a negative, right? You can't have a negative distance. If it's equal to 0, it has exactly 1 solution. If it's equal to a positive number, it has exactly 2. This number is positive and it's equal to it, so it's going to have 2 answers or 2 solutions, All right, that was my attempt to start writing the word answers, and I decided I didn't want to. So the way you do this is 7x plus 2 equals 3, or you never change what's in the absolute value. Leave 7x plus 2, but you change everything else. If it's equals, all you're going to do is turn an equals around. Well, guess what? If I take equals and I flip it around the other way, guess what? It still equals. So this is equals, and then I change the 3 to what? Negative 3. So you do it every time. So then we solve each one of these and see what we get. Going to subtract 2. 7x equals 1 divided by 7. X equals 1/7. Here we're going to do the same work. Subtract 2, but this time we don't get 1. We get negative 5, right? Negative 3 and negative 2. Divide by 7. X equals negative 5 over 7. Oops. So then I have both answers. X equals 1/7 and negative 5 over 7. Make sure it looks like a 7. Which you're picking multiple choice. And that's going to be B. Right? B for number 17. B right here. Oh, here's another solve on 18 here. So is the absolute value by itself? No, so we need to take this and move it over. So we have 7x plus 5 in absolute value minus 4 equals negative 13. How do I move this over? I add it to both sides, right? Just like this were just y, some variable, x, m, q, p, whatever. That cancels. 7x plus 5 absolute value equals negative 9. So here, if you get something that is positive or 0, right? Absolute value can only be positive or 0. And it equals a negative number. When does a positive equal negative? Never. 0, never. So this, no solution. No solution. Or we can write it as the empty set, which is this right here. Okay? Since they're using set notation with the squiggly brackets, it is important that they use set notation when there's no solution. They don't just say no solution. They have to go in and say it's an empty set. There is no set of numbers that works. The set that works is completely empty. Domain and range, if you recall, ordered pairs are x comma y. This is the domain. And this is the range. So that means the first of the two ordered pairs is the x. The second is the y. So the domain, I'm going to call that capital D. And the range, I'm going to call capital R. Capital D is equal to what? 4. That's 4. And then we have 4 again. We don't write it again. 2, negative 10, and negative 4, right? So 4 twice, and then 2, negative 10, and negative 4. What is the range? And by the way, this has to go in squiggly brackets. It's a set of numbers. Negative 4, negative 3. You say, where'd you get those from? Negative 4, negative 3, the y value's there, right? And then negative 4, negative 3, negative 9, negative 2, and 1. Right? Negative 9, negative 2, and 1. And that's the domain and the range. So how do I do this here? Well, look for the domain. 4, negative 4, 4, negative 10, and 2. Let's see. 4, 2, negative 10, negative 4. All right, so that's it right there. All right, that's that one. And then, wait, let me go ahead and just take all those out. And then the range, negative 4, negative 3, negative 9, negative 2, and 1. These all match up here just like they did there. So D, number 19, is going to be D as well, just like number 18 was D. Solve the linear inequality. So we have this inequality here, 6x plus 2 is greater than 2 times 2x plus 3. So we want to solve it, number line, and then interval notation. So let's go do that. First thing I need to do is simplify both sides before I start moving stuff around. Can't do anything over here, so it's time to move to the other side. 2 can get distributed because nothing can be done inside there, right? So this is going to be 6x plus 2 greater than 4x plus 6, right? I got to distribute 2 times 2x is 4x, 2 times 3 is plus 6. And then I'm going to move my 4x. It doesn't matter. That cancels. If I do that, I also want to move what? My plus 2 here. So we are left with 6x minus 4x is 2x is greater than 4. And then I divide both sides by 2 and get x is greater than 2. X is greater than 2. Well, then on my number line, what number do I care about? 2. Which way is greater than? And what goes around 2? There's no equal, so it's going to be a parenthesis, right? So 2 to infinity is going to be my interval notation. This is infinity. So 2 comma infinity is my interval notation. And that one is, looks like not C. Or is it C? Hang on. Oh, yes. The graph is below it. C. I was looking at the graph above it. 2 to infinity, and then this starts at 2 with the parentheses and goes out here forever. Has the arrow shaded. So that's going to be C for number 20. Answer choice of C. 21. Let's see. Unless I went out of order again. I don't think I did. I think that was the only one. Aha. 21 and 22. Both on this page. Good. Compound inequality. So we have 10 is less than 5x is less than or equal to 35. Does this thing make sense from the get-go? 10 is smaller than something that's smaller than 35. So is 10 smaller than 35? Yes. So we're good. Now we want to get x by itself in the middle. Is there anything added or subtracted? No. So then the way I do that is I'm just going to divide this by 5 everywhere. Both sides in the middle. This side in the middle of these two things here. 10 over 5 is 2. Less than or equal to 5 over 5 is 1. So this is x is less than or equal to. Oh, I see something that's extra here. That doesn't belong. And so what is 35 divided by 5? 7. So this becomes 2 over 1. This becomes 1 over 1. This becomes 7 over 1. So no more fractions, which is glorious. So 2. So on my number line, I care about 2 and 7. So I'm in between them. Parenthesis on 2, and then this equals means what? We have a bracket over here. So 2 to 7. All right, this is written right because we would have, I should have written it. We have 2 comma 7 parenthesis with a bracket. So this one's written right here, and then this 2 goes all the way out to 7. Yep, this is it right here. So 21 is D. There, 21 is D. 22, find the piecewise function, the value of it. Well, how on earth do I do that? Well, the first thing you have to do is determine which piece you're using. So see, it says f of 0. X is greater than 0. 0 is not included in that. There's no equals, right? So x is less than or equal to 0. F of 0 uses this one. So here it is. Negative, and you're plugging in 0 plus 1. So equals negative 0 plus 1. So that equals, I'm sorry, negative 1. Negative 1, which is D. Another page where it's all D's. That was 22. So 21 and 22 both D. 23. Here's an absolute value less than. Remember, less than and greater than are done differently. This one's less than. So again, I need to get rid of this and move it over. So I have x plus 6 plus 1. This is an absolute value, by the way, x plus 6. Less than or equal to 4. I'm going to move the 1. X plus 6 in absolute value is less than or equal to 3. And now I'm ready to write absolute value less than is let us make a sandwich. What does my sandwich look like? Well, x plus 6 is sandwiched between 3 and negative 3. Notice that this and this both point to the left. You cannot have them pointing in opposite directions. It cannot be right if that's the case. So remember, you do an and or for the greater than is a great or. But here this was an and. It was a sandwich. We made that sandwich. So what do I do to finish solving? I need to get x by itself. I need to subtract 6 in all three places. So then negative 3 and negative 6 is negative 9, less than or equal to x, less than or equal to what? 3 minus 6 is negative 3. But wait a minute. I got to add 3. Oh, I messed up. No, that's right. I had it right. I'm sorry. I think I did. So x, the plus 6 is gone, right? Negative 9 is less than or equal to x. Is less than or equal to what? Well, negative 3. And now that's simplified. There is no more dividing by x or finding out something else. 9 is less than or equal to x is less than or equal to 3. That's an inequality. That's not over here anywhere. My number line, I care about what? I'm negative 9. Negative 9 and 3. I share it in between. They're brackets. That means you use, or they're included. They're equals. You use the brackets. So negative 9 comma 3 is your interval. So do you see any intervals that look like that? Negative 9 to 3. I don't. What, did I mess up a sign? Oh, I did. Look, here's what I did wrong. Look what I did. This is good and carelessness and looking back. What is this? It's a negative 3, isn't it? What did I put here? Should have a negative there, right? So that should be negative. That should be negative. I'm glad it didn't have the other answer because I would have just picked it and missed it. So negative 9 and negative 3, both brackets. It's D right here. And then you just check to make sure the number line really goes from negative 9 to negative 3, and it does. So then that's going to be D. So another D right there, right? I think the last page both were D's. And then we move on to 24. For the given functions, find the indicated composition. And let me go ahead and say this about this one. It's a little funny looking on here. I hope it did better in Canvas. This really is G composed with F of X. So it's what you would expect it to be with a composition here. G composed with F and then of X. So, how am I going to do this? I'm going to do my G of X in pink and my F of X in blue. So this really means G of something. G of F of X. And there's a couple of different ways you can go here. My favorite way is this way right here. So I'm going to say this is going to be G of something. But wait a minute. What is F of X? F of X is negative 3x plus 2. So the rule for G says 6 times whatever you have there plus 2. The other thing is you could bring F of X down. I've already subbed it in. I'm going to bring it down. Plug it in where it belongs. So then this is going to be negative 3x plus 2. Oops. And now distribute, right, negative 18x plus 12 and then plus 2. So negative 18x plus 14. And that, my friends, looks like answer choice C. Hopefully that's what you got to see. And then 25, the last one on this review. Find the inverse. Right? So the first thing we do is we swap this out and put a y, right? So we're going to say y equals 7x minus 1 over 4. Remember I gave you 4 steps. Then we swap the x's and y's, meaning everywhere we have a y, we write x. And everywhere we have an x, we write what? Y. Don't need a parentheses there, over 4. So how do I do this? I'm going to take and solve for y. I want to solve this by itself. So I need to get rid of the fraction first. Always eliminate fractions if I can. I don't like fractions there. Eliminate them first thing. So then those divide out because they're over 1. And then here it's going to be 4x equals 7y minus 1. And then the way we do this is we have to get rid of this minus 1, right? We undo addition and subtraction before we multiply or divide. That cancels. 4x plus 1 equals 7y. And we want y by itself, right? So we're going to divide by 7. 4x plus 1 over 7 equals y. And then the last step is to take this and replace it with what? F inverse of x. So really F inverse, and I'm just going to write it first, equals 4x plus 1 over 7. Which in this case is answer choice B, right? F inverse of x is 4x plus 1 over 7. And that concludes our review for college algebra midterm online.